All right, so we're going to talk about space, right? And space is exciting, right? Lots of cool things dealing with space. I do have a lot of videos for us to watch today because, again, it's children. Videos are cool, especially when we're talking about space. They're not things that I could easily demonstrate in class, so videos are a great go-to here. I wanted to start off by saying Gustavus in space, right? So, for those of you who don't know, Buzz Aldrin is actually an honorary doctorate from Gustavus, right? When he went to the moon in '69, he had already become a graduate, right? An honorary doctorate holder of Gustavus, and so he was a Gusty on the moon. It's pretty cool. He actually donated some patches and a flag that went to the moon with him. I currently don't know where they reside, if they're in the physics department or the library or somewhere on campus. That's a great question. And you know, we actually just gave somebody a doctorate in the Nobel Conference. So, yeah, it's more or less meaningless, but it's an honorary title. So we can say he's an honorary Gussie, right? He did not attend classes here. So I don't know if any of you attended the Nobel Conference and saw the guy who was a Nobel laureate. He was honored with an honorary doctorate from Gustavus. I don't know what led Gustavus to give him that doctorate. I think it was something like 10 or 11 institutions gave Buzz Aldrin an honorary doctorate, and we were one of them. So, yeah, pretty cool. I found this out last year. I'm like, oh, I have to share this with the class. All right, so we're talking about space, right? Where is space? Well, that's actually kind of hard to define, as maybe you listened to in that video there. Generally, we're going to say that space is above the Earth's atmosphere, right? But where is above the Earth's atmosphere? That is a little bit undefined, right? So the Earth's atmosphere extends way, way outward into what we call the exosphere here, which is about 6,200 miles above sea level, so pretty far out there. Even though when you get to that point, the atmosphere is very, very, very thin, right? So it's barely an atmosphere at that point. For reference, right, some other notable things that are in space, like the International Space Station, the ISS here, is only about 250 miles above the sea level, right? So still technically within Earth's atmosphere, crazy enough. The Hubble Space Telescope is 340 miles above sea level. Satellites can get up to about 38,000 miles above sea level. That varies depending on what satellite we're talking about here. The James Webb Telescope, which made big news last year or the year before, that's actually like 1,000,000 miles above sea level. That one's way out there here. So just to give you kind of a reference of where space is here, right? But generally, when we say where is space, right, we are going to say that it is at this Van Karman line, right, which is 100 kilometers or 62 miles above sea level, right? That's actually not too far away from sea level, right? If you think about St. Peter, right, and draw a radius of 62 miles around St. Peter here, so St. Peter is my little red dot, you can make it to almost the St. Paul area here. Right? That's not a crazy far amount away. But when we're talking about going straight up, things change pretty drastically pretty quickly. Right? Van Karman line is generally agreed upon as where space begins because it's the point where traditional aircraft can no longer fly, right? Instead of relying on their engines, they must rely on like propulsion systems. So you just can't fly that high. The air becomes really, really thin, can't provide any lift. We're going to some more physics here that is a little bit beyond my area of expertise. But Van Karman line, 62 miles above sea level. That is where we are going to agree that space has begun. Yeah, no, very cool. In fact, the same thing has to happen with the ISS too. We have to periodically bump it back up so it doesn't fall out of orbit. Yeah, yeah. No, very cool. Awesome. That sounds like an amazing experience. Where did you do that at? Montana State. Very cool. I imagine lots of clear skies.
Yeah, I mean, most of it's not, most of it's doesn't matter about the clear skies, right? Because that's most of the time. It's a clear
Oh,
skies, but I mean, it's not that. It's
that's
like,
very
all
true.
that crap is we see all the time with photography.
Yeah, very neat. All right. So where is space? Dan Farman line. That's just generally agreed upon. What is in space, though? There's a lot in space. There's also a lot of nothing in space, right? If we think about man-made objects, right, there's a lot of man-made objects that orbit the Earth. In fact, it's actually kind of like a space junkyard in a sense. We have satellites, right? We have the space station, solar system probes that give us data on everything else out there. We have devices on other planets like the Mars rover. I think there's a probe that went to Venus, if I'm remembering correctly. A lot of space junk, right? So a lot of times when these things break in space, they don't get sent back down to Earth, right? We just kind of let them leave our orbit and kind of exist in space. And so there's actually like they call it like the space graveyard, right? There's a term for it, for just this entirety of just junk surrounding the Earth that no longer has a functional purpose, right? So there's a lot of man-made objects out there, mostly centered around Earth, right? But there's also asteroids and comets and meteors, right? We're not going to go into the distinction of what they are, but if you are interested in that, I do have a little YouTube video here that you can watch. But because we're really talking about man-made things in space and sending things from Earth into space, particularly plants and seeds, right? I'm kind of focusing on what have we sent out into space. What does space consist of, right? Well, space can be extremely cold or extremely hot if you're close to the sun or other stars. It's a vacuum, which means it's devoid of matter. There's lots of radiation, particularly from the sun, and there is no gravity. Right? So we get a lot of microgravity. I should say there's no gravity. It's very, 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 very little amounts of gravity, right? Often called microgravity. In a lot of popular culture, you'll see people say that there is no gravity. Because really, it's like you have no gravity. So if we were to go up into space, how would a vacuum affect humans? Well, this is actually quite interesting. What would happen if a human went into human survive in space? Well, short answer is yes, if you're protected, right? If you bring an atmosphere with you. Radiation tends to be the biggest concern. Radiation can damage like the DNA in your cells, it can cause mutations, it could eventually lead to types of cancers. So the sunlight, UV radiation here on Earth, right, if you don't protect your skin with sunscreen, you could end up with skin cancer. Right? But that radiation is just intensified when you're out in space. So yes, we can survive protected in space, right? Without a spacesuit, no. But you will actually survive a little bit, right? It's kind of generally agreed upon that I think you could survive 14 seconds in space while maintaining consciousness, and then up to 2 minutes while you're unconscious. Right? Your body's not going to like it. Things are going to go awry in your body, right? You're not going to come out of that unscathed, right? But you can survive for a little teeny tiny bit. Essentially, that boiling point of liquids are going to decrease, like you saw in that video here. So you're going to get a lot of evaporation out of any openings on your body, your mouth, your nostrils, your eyes, right? They're going to start to boil. Air is going to be sucked out of your lungs, like you saw those little shriveled marshmallows at the very end there. And your body will freeze, right? Because most of space is very, very cold. And again, This is a very video heavy lecture here because all right, so if we think about our solar system, right, we know what'll happen, what is in space, what space consists of. We think about just our solar system here, right? We have the sun, we have 8 planets, many asteroids, many moons orbiting all the other planets here. So an asteroid we would define as a rocky body orbiting the sun. You often see, like these very cratered giant rocks. You see visualizations of asteroids in space here. A planet, on the other hand, is going to be defined as something that orbits a star, has enough gravity to cause it to be spherical, and it's cleared its orbit of any other space objects. Right? So basically, it's the only thing in its orbit. An exoplanet is the same thing as a planet, except it's a planet outside of our solar system. And so when we do our final project, we'll be looking at science fiction stuff. We see the term exoplanet quite frequently, right? It's a planet, just not in the Milky Way in our solar system, right? So Pluto, all right? Pluto is not a planet. What is that? Justice for Pluto. Yes, it was defined as not being a planet because I believe it has not cleared its orbit of all the other space objects. So it's very, yeah, it's a minor thing. It's not a planet according to our current definition. Right? It's one of those things that as science progresses, we learn more about objects. Right? We have the technology to learn more, and we can redefine how things are placed into these categories. So our galaxy, right, if we expand out of our solar system and think about our galaxy and the Milky Way here, we have a spiral galaxy. You can see that in this image here. It's very much this spiral-like shape here. It actually has these 4 arms. If you look closely, it's kind of hard to see because it's a very cluttered spiral. But we can see kind of 4 arms radiating out from the middle here. Right? So for example, this would be an arm. This is an arm here. You have an arm here. Oh, and I think that 4th arm is this little arm right here, if I'm looking at it correctly. All right. It's defined as having 2 major arms and 2 minor arms. So the major arms are the easier ones to see here. They're these big, broad arms. Right? These minor arms are these smaller arms coming out. Now, the sun, where we are located, right, is in the Orion arm, right, located between the Sagittarius and the Perseus arm. Right? I don't expect you to know this, but I think it's a cool fact to look at how our galaxy is just this little dot in our spiral galaxy. And kind of a fun fact about these spiral galaxies is that there is so much stuff when you look at it from a plane. So if this was like the plane of our galaxy, right? It's spiraling around in my hand. If I were to look at the galaxy like this, there's going to be so much stuff in the way that I'm not going to be able to see too far into space. But if I were to look out from my hand upwards, right, or directly out on either side of that galaxy, right, so like up or down, right, you can see quite a bit into space. There's nothing blocking your view. So what we know about space is pretty much what we can see by looking directly up or directly down from that spiral. We don't know a whole lot if we were to look through the clouds of, let's say clouds loosely there, through all the space material that's in these spirals, because it's blocking our view. It's a kind of a fun fact there. Who knows what is hiding behind those spiral arms? Other galaxies, there's a lot of other galaxies, right? It's estimated about 2 trillion other galaxies, and which we know not a whole lot about. I mean, the 2 trillion galaxies, that's from the galaxies. Are there other habitable planets out there? Maybe, right? So I have a link here that I'll go to now, and this is actually a list of what we think are potentially habitable worlds that are out there. Now, are they close enough that we would probably ever travel to them in our lifetime? Probably not, right? But there are other planets out there that we think could be habitable. Do they already contain life? Up to debate, right? We do not know. We just don't have that data. So we want to learn more about space because there is so much out there. And there's many, many space agencies out there dedicated to study and explore space. Some of the more prominent ones tend to be NASA in the US here, the European Space Agency, ESA, right? That kind of encompasses Europe. CNSA, the China National Space Administration, is the Chinese version of NASA and ESA. Roscosmos is the Russian agency. JAXA is the Japanese agency. Right? These tend to be the big players when it comes to space exploration. But almost every country has some organization dedicated to space travel. They may not be as fortunate to be as developed as, say, NASA and ESA, right? But they're still out there. They exist, right? So these are kind of our big players, right? Now, if we kind of make that transition from studying space to studying plants, many of those agencies are going to study things like long-term space travel, right? And when we think about long-term space travel, think about that new space race to get to Mars first, here. We have to figure out how to provide food for our astronauts, right? So we're going to look at how to provide fresh foods in space. We want to understand how plants work, or the plant physiology, right? So are they going to grow differently? Or can we expect them to grow relatively the same as we would see with, on Earth, under Earth's atmospheric conditions? But as well as if we understand plant physiology better, right, that's going to help us understand plants here on Earth, right? And how we can improve agriculture on our planet and not just in space, right? So if we're thinking about plants in space, right, exposed to all these conditions, what do plants need to survive? Well, there's some pretty common basics among all plants. They all need light, right? So we need light. They need to be able to photosynthesize. That makes food for them to be able to grow and eventually reproduce, right? We need moisture. We need water, right? I'm sure some of you have seen very wilted plants out there that have not had any water. So we need to provide them with water. They need things like nutrients. Right? Just like we need to eat food to get our nutrients, plants also need nutrients. Yes, they can make some of their food through photosynthesis, right? But they also need things like phosphorus and potassium, calcium, magnesium, right? They need those nutrients that are found in soils. And if we think about growing plants in space, we need a lot of soil in space. Plants need air, right? So we need to provide plants with air. As part of being able to photosynthesize, they have to take in carbon dioxide, right? And when they take in that carbon dioxide, they'll photosynthesize and they'll release oxygen back out, which we benefit from, breathe in that oxygen. Right? So plants need air, they need some sort of an atmosphere, and they need a proper temperature. Right? If you look outside right now, you're not going to see a lot of plants actively being green and alive. Right? It's too cold. The opposite is true as well for heat. Right? Too much heat is also a bad thing for these plants. They just cannot cope. So we need to have that proper temperature regulation. Right? And so if we think about growing plants in space, we have to meet all of these requirements, but the plants also have to deal with radiation. Right? So just like UV radiation from the sunlight on our skin that could cause cancers, UV radiation and other types of radiation can cause cells in plants to mutate slightly. To what extent? Still being studied. They have altered gravities. Right? If we're growing plants on the International Space Station, they are exposed to a microgravity. Right? Cold and heat stress, depending on where you're looking to grow these plants. Right? Maybe different planets, we have to adapt to the right temperature. Mars is very cold, right? If we want to grow plants in Mars, we have to figure out a way to keep them enclosed in something to make them warm, and as well as just different atmospheric conditions, right? Plants evolved here on Earth, which means they're adapted to our Earth's atmosphere, right? Having carbon dioxide in the atmosphere. Other atmospheres might have more or less or absolutely no carbon dioxide, right? So we have to think about how they might respond to these different atmospheres. All right, so I want us to do a group activity, right? And I just want us to explore a planet in our solar system. I'm going to have you get into groups of, well, I need 8 groups total, so that's about 2, some groups of 3 out there. I'll let you pick your groups for now. I know I did it randomly yesterday. As a group, I'm going to have this random wheel that will spin, that will give you a planet to study, right? I want you to draw your planet, so I'm going to utilize these chalkboards, given that I can get this screen up, which GPS told me we fixed. So hopefully that works. And I want you to describe its conditions, right? Particularly paying attention to how much light does it get, right? Is there any like soil on the planet? What is the atmosphere like? What is the temperature like? Right? So very basic descriptors of your planet. After you have done this, I will call on each group to kind of give a very short 30-second, 1 minute presentation to the rest of the class on what you have learned. All right, I'm going to go ahead and have you sort yourselves into groups, and I will moderate as needed here. I'm looking for 8 groups. If we have less, that's fine. I see us roughly in 8 groups here. Ellie, are you paired with a group? Yeah. All right, so I see 1, 2, 3, 4, group of 3, 5, 6, 7, 8. All right. Let's start on this side of the room, and I am going to spin the wheel, and you will get your planet. I also include the moon because when we talk about astrobotany, we'll be talking about plants growing on the moon. And yes, I love this wheel. This wheel will show up many times. All right. You have Venus as your plant here. Not plant, planet. All right. Next group, I'll do this group in front here. All right. Oh, Neptune. All righty. Let's see. I'll go with my back group of 3 there. It's going to be Jupiter. It's going to be Jupiter. All right. I'll bounce to my next group there. Looks like it's going to be Mercury. All right, I'll keep going over here. You get the moon. Let's see. I'm going to bounce in front here. So Eli and Mary. Saturn. All right, my back corner there. 2 options left. What's it going to be? Oh, all right. And I heard it's correctly pronounced as Uranus? Yes. I would accept either way. And that leaves Mars for our last group. So go ahead, start doing some research. I'm going to erase the boards and divide it into some spaces. When you're ready, come up to the board, draw your planet, and write out some essential facts. Let me write it on the corner here. Yeah, if there's an eraser there. Perfect. Light, air. All right, so think about how much light does it receive, what the atmosphere is like, so the air quality, any nutrients that might be present, that might be a harder one, do your best, and the temperatures present on that planet. All right, so like I mentioned for this class, we are really going to focus on 3 potential areas where plants can be grown, right? One being Mars, right, because there's talk of eventually putting a colony on Mars. The other is the moon. There's actually plans for a moon base in, NASA has plans. I think it's like 10 years out. It's sooner than I would expect, but it's could potentially happen in our lifetime. And the other is space flight, right? So a lot of times, we're not going to grow plants on these planets yet, but there are plants currently being grown in spaceflight that have those conditions of microgravity. They have the breathable air, right? Humans can survive there. Plants can survive there. The radiation is shielded on the International Space Station and in a lot of other space flight conditions. There is limited space though, so it's not like you could have an entire greenhouse on the International Space Station. And because of that limited space, literally everything on board has a purpose. So if we're growing plants in space, right, that entire space is going to be very compact. Every little nook and cranny is going to have a purpose. Even anything else you might find on board, regardless of whether we're growing plants or not, right? NASA has kind of an inventory where everything is located on the walls and the ceiling of the International Space Station. Are there any questions about this lecture? I do have it up here. I have another questionnaire up on Moodle that if you have a question and you just don't feel comfortable asking in class, you can ask it anonymously. I don't collect your names, and I will answer it on a subsequent lecture. Or you could talk to me after class, whatever works for you. All right, I wanted to move and talk about homework for tomorrow. So again, I'm going to have you do a couple of readings and a video, do that daily quiz. So I have those 3 links there, right? The book Endurance, we will have a discussion on that next Tuesday, and that'll be chapters 1 through 5 if you want to get a head start on it. It's a pretty easy read, I would say. But for that discussion, I am asking you to prepare 3 discussion questions, uploading it up onto Moodle, so you're prepared to discuss in class. Each discussion question, I think, is worth 1 point. I think I have 3 discussions at 3 points each. Let's see. Exam 1. Oh, I have it on Thursday. That's supposed to say Friday. Friday, January 12th there. But what I really want to talk about, right, is this brainstorm due for the final project. So I want to introduce what the final project is going to be in this class, right? And essentially, we are going to fact-check astrobotany in some pop culture piece, right? That pop culture piece is for you to choose. I do have a couple that are off limits, 2 of them being a WALL-E, because it's almost too easy, right? There's a plant flying around in open space. It's almost too easy to analyze. And The Martian, because we will be watching The Martian in class. And again, there's a lot of research out on The Martian. It would be kind of an unfair advantage here. So those are the 2 that I do have off limits. But essentially what I want you to do is read, watch, board games and video games with astrobotany out there. I mean, some sort of pop culture that shows plants in space, right? The limitations being that it has to be plants grown on either Mars, the moon, or in space flight, because we actually know things about growing plants there, and it's easier to fact check, right? Rather than, I know the book Dune, right, has a lot of plants growing and has a really good section at the end, right? But it's not a real planet. We can't fact check it, right? So it has to be something that you can actually fact check. So I'm going to limit you to Mars, the moon, or space flight. Though if you find something and can make a reasonable argument, I will hear you out, but I have not had one that I have actually been able to check off yet, because you can't fact check something that doesn't exist, right? What I'm going to assign for you all, right, I'm going to let you choose your groups. I'm going to say groups of 2 to 3, right? I'm going to let you choose, because I know some of you know each other here, and I want to take it to be fun. If you need a group, I will happily assign somebody to a group. What is due tomorrow is just a brainstorm of ideas, right? I want you to come up with a list of 4 possible ideas that you as a group would like to explore, right? Again, it could be anything in pop culture, right? I've seen board games, video games, movies. There are a lot of books. I have not had anybody do a book yet, because you have to read a book. I get it. It's understandable. So that brainstorm will be due tomorrow, right? And then on Monday, what we will do is we will go through the classroom and kind of finalize who is doing what. Because I anticipate there being a lot of overlap in this list. So, for example, if 5 people want to do the same board game, right? Only one group is going to be allowed to do the board game. I'm going to bring out the wheel, right? Sort of randomized who is picking when. So make sure you have backup options, which is why I'm asking for a brainstorm of 4 ideas. Throughout the semester, I will have you do an annotated bibliography so you can find some sources to help back up your claims. There will be a final paper, right? In the past, I have left the final paper a little bit more open-ended. I think I'm going to give you an outline this year, because it's a lot of writing for me, and I feel like this is not a writing class, and I don't want you to stress out over the writing. So I'm going to give you a bit of guidance there. Forthcoming. You'll give a presentation to the class, right? So everybody can learn about your pop culture piece and what is realistic and what is not. And then I'm going to have you do what I'm calling a newspaper review. All right, so kind of, you know, in the older days, you read a newspaper and you find the review of a movie in the newspaper to see if it's worth watching or not. Nowadays, it's more like Rotten Tomatoes or IMDb, right? I want you to do some sort of a creative review that we can display in the hallways of Nobel. So actually, when we go down to the lab after we take a break here, there are some previous displays in that hallway that you can feel free to look at. I did bring one here. This did not print right, so I did not display it. You can see the printing got really weird, so I had to reprint it. But this group came up with, instead of BuzzFeed, it was BudFeed, all right? And they wrote an article as if it was a BuzzFeed article. So you can be creative. I encourage creativity. All right, any questions about what I'm asking you to do? All right, I have one more thing before we take a break here. I am going to go to, well, my next slide here, well, that says 3, it should say 4. Is kind of the overview of what I'm asking you to submit tomorrow. So I'm just looking for you to upload a PDF document, make sure all of your names are on it. I only need 1 document uploaded per group with your 4 ideas. Right? So I put an example up here. I am looking for you to mention what it is, what format is it a movie, is it a video game, where it's located, right? So is it Mars, moon, space flight, or something else you want to argue for, right? And how are plants mentioned or utilized, right? So in the Martian, plants are grown for food, right? This same instruction is up on the Moodle site. Let me make this a little bit bigger here. All the way at the bottom, I have a whole set up for just your final project, right? Final project assignment, if you click on that, it will take you to a document that outlines what I just explained. That will be your final project, right? Kind of giving you a background, giving you the topics that I would expect you to discuss in your paper, in your presentation, right? As well as kind of the due dates for everything. Also on this page, right, is where you will submit that final project brainstorm, right? So that PDF document, and yes, make sure it is a PDF document because logistically it makes it like 10 times easier for me to grade PDFs. But I also included this list of some possibilities because I've taught this this is my 3rd year with this course. I've gathered a list for you. You are welcome to use something outside of that list, but if you click on that link, it will bring you to a whole list of things that either have been used in the past, suggested in the past. The ones in red are the ones I'm saying you cannot use. So WALL-E is in red, Dune is in red. I don't have the Martian on there, but Martian would be in red. There's some other possible additions that I have not personally verified or had anybody verify if you wanted to look into, right? I do have access to some of these, not all of them, if you're looking for access. So when you're thinking about what you want to choose, make sure you have access to it, right? If you need to order it through the library, or if it's on Netflix or Hulu, right? If it's a board game, if you have the board game. I do have one board game that I would be willing to loan out to a group. It is a very complex board game, but I've had a group do it in the past. It's Terraforming Mars. And I have a couple of books I'd be willing to loan as well. All right. Any questions on that? Yeah. That is what Monday is for. So on Monday, make sure you have a list of like top 3, top 4, right? And people might pick what your top number 1 was. We will discuss it all as a class. I will give you final approval. Then you'll submit that so I know what everybody's doing. So have a variety of options. Any other questions? As we go through the semester, you will gain the knowledge to actually practice this. So I wanted to introduce it early in case you had to search down a resource. All right, I'm going to say let's take a 15-minute break. So we'll come back at 12:20. But when you come back, I want us to meet in the lab. And the lab space is directly below us here. It's in 2104. Right, you'll see some Astrobotan posters in the hallway outside of it.